Now we shall define also the excess demand correspondence. Which will be denoted by Z. This excess demand correspondence is defined by means of a supply and demand correspondences over firms and over households, of goods. This correspondence is defined in lambda and takes values in the n-dimensional Euclidean space. We shall have that a vector z belongs to z of p if and only if there exist optimal production processes for every firm and optimal consumption bundles for every consumer such that stiamo qui, let us write here z is equal to the sum for I which ranges from 1 for h which ranges from 1 to large h of xh minus sum for h which ranges from 1 to large h of omega h minus sum for f which ranges from 1 to large f of yf. This is the definition. Well, right, and then I shall explain. This is point. What is the meaning of this definition? It's simple. Take any price system P, according to which every firm is able to maximize its profit. And Y1, Y2, etc., YF are optimal processes for the corresponding firms. Now, it is possible to compute the wealth of every consumer, and suppose that every consumer chooses this optimal bundle, x1, x2, xh. So we have the following. This is a vector, clearly, the sum of the consumption bundles of the different households. It represents the vector of total demand which derives from the household themselves. From these we subtract the total endowment of goods of the same households. If in our economy there were no production, the definition of Z would be simply this. I subtract the initial endowment from the total demand of every good. You obtain the excess of demand, which is a positive or negative number, according to the fact that demand excesses supply or vice versa. But here there is also production. So, you must subtract from the total demand not only the total initial endowment of goods, but also the quantities which are produced by the firms. if they are positive. Or added the quantities of goods which are demanded by the firm in order to produce other goods. So the excess of demand is represented by this difference. I repeat. The total demand of goods by the households minus the total initial endowments by the households minus the quantities produced by the firms or plus the quantities of factors employed by the firms itself. Clearly, if a good is employed as a factor, there is not only the demand by the households, but also the demand by the firms of that good. This is the definition of excess demand correspondence. Clearly, given P, there are many vectors Z, since there are, generally speaking, many optimal processes for every firm, many optimal bundles for every consumer, and so on. To employ this excess demand correspondence is very useful in general economic equilibrium. Otherwise, you must in every moment consider individual supply function, individual demand function, and so on, and representation of equilibrium would be very, very difficult. This excess demand correspondence verifies a very, very, very important property, the well-known variance law. It has write it this way. Variance law. Variance law tells us that for every P in lambda, for every Z in large Z of P, the value of Z is less or equal than 0. This is variance law, the weak variance law, more precisely. Moreover, if the preferences of every subject are monotone or locally non-saturated, you remember, then this condition holds as a strict equality. And you obtain the strict variance law or strong variance law, etc., etc. In other terms, the total value of all the excess of demand is always a non-positive number. And in the case of locally non-saturated preferences, it is exactly equal to 0. Note that this condition holds for every price system, not only for an equilibrium price system, because in equilibrium, as we shall see in a moment, since every excess of demand is equal to 0, clearly this equality is surely verified. But in reality, it is verified also for other price systems, for every price system in lambda, of equilibrium or not equilibrium. It is a substantial, an aggregate budget constraint, which tells us that in the whole, the economy cannot buy goods whose value is superior to the total initial wealth of all consumers. Let us demonstrate this very, very important result. cancellato, va bene. Since this vector z is the sum of these elements, these vectors xj, omega h, yf, h, we have the following. For each consumer, the value of xh must be less or equal to the value of the wealth. Do you remember? This is the wealth of a consumer. According to the definition of a budget constraint, the value of xh, the bundle which is chosen by the h households, does not exceed the wealth of a consumer. Very simple. Now, put attention. Z is a vector. Clearly, also this sum is a vector. Now we multiply both sides of this equality by the price system. So you have here P times Z, which is the total value of the vector of excess of demand. We must prove that this value is not a positive number. And similarly, you obtain the same result here. So you have P times Z equal to sum for H, it has right in this simplified form. It's a simple analytical step. I have multiplied both sides of this equality by the price system. So clearly, these and these now are real numbers. But remember that our YFs are optimal for the corresponding firms. So their value must be equal to the profit of the F firm. Rewrite sum for H of P times XH minus sum for H P times omega H minus sum for F of pi F of P. I repeat, YF is chosen in the production set of the F firm as a process which maximizes profit. And so we can substitute pi F to this inner product. Is it clear? Now, we know that each pi times xh is less or equal to this. So this inner product reappears here. There is a sum, clearly, because we are considering all the subjects. Therefore, this is lesser or equal to a sum for h of P times omega h plus sum for h, sum for f of xi f h times pi f of h minus sum for h of p times omega h minus sum for f of pi f of p. Ah, sorry, Now, put attention. This sum and this sum can be simplified. What remains? This is the total sum of profits of the F firms. But here, there is the same magnitude. Why? Because note that pi f does not depend on age. So you can invert the summation index in order to write in this way. You have sum of f for f which range etc. of pi f times sum for h of the shares in the property of the f firm given to each household. But this sum, by assumption, is equal to 1. So we can cancel it. And you obtain the sum total profits of the firms minus the same sum. Z. Conclusion, you have that the total value of the excess of demand etc. is less or equal than Z. The theorem is proved. In the particular case, which preferences are monotone or locally non-saturated, you remember each consumer has an expenditure which is equal to his initial wealth. So this condition is verified as an equality. So here there is an equality, and in conclusion, P times Z is equal to 0. Strong Varro's law in the case of monotonicity or local non-saturation. Then write all these passages, these steps, and then I shall repeat the proof. We defined the excess demand correspondence. Now we want to prove Varro's law. Take any price system according to which every firm is able to maximize its profit, and every vector of excess of demand, the value of that vector, the value of that vector cannot be a positive number. Weak Varro's law. And if by chance preferences are monotone or more generally locally non-saturated, value of Z is exactly equal to 0. Strict Varro's law. The total value of excess of demand is null. Well, each of these XH, which are demanded bundle, clearly must be also purchasable bundles. And so for every H, this inequality is verified. The total value of XH must be no greater than the initial wealth of H consumer. Now, consider the definition of excess of demand Z. Multiply both sides of this equality, vector equality, by P, the price system. you obtain P times Z equal to P times this vector. In other terms, this equality. This is simply a mathematical step, an algebraic step. But remember that each process YF is an optimal process for the VF firm. And so its value must be equal to the profit of the same firm. So you can substitute to every P times YF, pi F of P. At this point, combine this expression with this inequality. For every H, this inequality must hold. So you simply write minus or equal to this expression. It is a fortune that the total value of initial endowments can be simplified. It remains the total value of profits minus sum for H, sum for F, Xi FH times pi F of P. But this double sum can be rewritten in this way: sum for F of the profit of firm F times sum for H of Xi FH. This is another algebraic step. But this sum is nothing but the sum of the shares in profit of the FM by the different households. And by assumption, this sum is equal to 1. So you can eliminate it, and it remains only the sum of the profits. Sum of profits minus sum of profits, 0. You obtain the desired result. The total value of vector Z is less or equal than 0. And since when preferences are monotone or locally non-saturated, each of these inequalities is in reality verified as an equality, you obtain here an equality, and therefore the total value of excess of demand of the goods is 0. Is it clear? It's a simple result, but extremely important result in general equilibrium theory. And not only in general equilibrium theory, for example, in international trade theory, is very fundamental. But stop for a moment.